This is Geometry, Unit 3.4, talking about proofs of lines and angles. The first vocab word we're talking about today are adjacent angles. Adjacent angles are non-overlapping. That means they don't share any common area. And they have to have a common vertex. They share a common side. Like this picture over here, they're sharing this common side. I like to shade in one of the angles. And we can shade in the other angle. And you can see they don't overlap at all. They don't have pink and gray in the same area. They share the same ray. They share the same side. It's like a fence line in your backyard. And it also has a vertex, the same vertex. That is requirement for adjacent angles. Now, one of the wordings that's incorrect here is here all of a sudden we're talking about vertical angles. So we're going to cross this line out. Adjacent angles are typically not an if-then statement that we'll need to talk about in our proofs. This vertical angles is something we'll talk about tomorrow. This picture that's drawn here, would we consider those adjacent? What do we think? Falling underneath the definition, do they have a common vertex? Do they have the same exact vertex? And do they share the same side? When you look here, this angle X has a vertex and it has two sides of its own, and this angle Y has two sides of its own and its own vertex. So no, they have two different vertices, two different pairs of sides. So not, or we'd consider that non-adjacent. These over here would be adjacent. So there's an example of adjacent angles and an example of non-adjacent angles. We'll see some more examples of non-adjacent in the future. A vocab word that's very important in geometry are complementary angles. You'll see this on your SAT and definitely your final exam. Two angles add up to 90 degrees. And they're sharing the same, they may or may not be adjacent. So here we have adjacent angles that are complementary, adjacent angles that add up to 90. And over here we have a 40. Looks like we've lost our 50-degree angle. Those would be complementary angles. They do not have to be adjacent. They do not have to share a side. They do not have to share a vertex. They can. These over here are adjacent and complementary. These are non-adjacent, but they're still complementary. They still add up to 90. Now, in our proof, we're going to use these statements in proofs. If two angles are complementary angles, then they have a sum of 90. You're going to end up writing that in your proof. As soon as you hear that they are complementary angles, you're going to make the statement that their sum is 90. If means it came earlier and then 90 degrees when we're writing out those proofs we've talked about in the past. Supplementary angles are very similar to complementary, except they have a sum of 180. They add up to a straight line. So here we see two angles that add up to 180. They have the same vertex, So these are adjacent angles, and they also add up to 180. So that's one way that you can have supplementary angles. We call this a special type of angle we'll talk about later. Here's 140. You could have a 40-degree angle and your 140-degree angle, and together they add up to 180. These are also supplementary. This second example, they are not adjacent. They do not have the same vertex. Over here on the left-hand side, these are adjacent angles. So more examples of what adjacent is from our first vocab word and what non-adjacent are. So if two angles are supplementary, then their sum is 180. The key term here is sum. There has to be two angles that add up to 180. Just like complementary, it has to be sum. It has to be exactly two angles, not three, and definitely not one. Has to add up to 180. So let's come down here and take a look at some different figures that we're going to identify if they are adjacent. So we got to add a little bit to these. We need to put an arrow on the end. Make this into angle A, or the letter A, with D out here on the edge. So when we look at these angles, you use your eyes, your finger, or even your pencil and trace out the order of the letters. BAC. From B to A to C. That's referring to this angle right there. Angle BAC. Then we have our other angle, CAD. Are those considered adjacent? Do they have the same vertex? Right there. They both have angle A as a vertex. That's where the V would be located. And they both share that common fence line if this was like your property of your backyard. So these are adjacent. Adjacent angles. This example number, letter B. These are going to come down. We're going to touch those here. We need to make some adjustments to this. This is F. This spot over here is going to be G. And up here, this will be H. So we're looking here at this figure. EFG. That would be this angle opening up. EFG. You want to use your eyes, your finger, your pencil, and trace out angle EFG. Then we're going to trace out angle HGF. So I'm using the pencil and doing some shading so I see exactly where my eyes are supposed to be looking. Notice how they overlap. They're sharing like the same backyard, as I use that analogy. They have to share the same fence line, not the same common area. You might say that they share this fence line, but it's kind of different than how they share this fence line, right? And they have two different vertices. This middle letter is F, this middle letter is G. We know right away that these are non-adjacent. Non-adjacent. We can zoom in here a little bit. Be sure everyone can see. Put your arrow on the end of the two that somehow it got cut off. This is an M out there. This should be an L and a K. So you want to label your picture. Those seem to have gotten cut off. Using your eyes, your finger, or your pencil. In my case, a highlighter. JNM. From J to N to M. There's your angle. So there's where you're looking at, the area that this angle is taking. It's opening up into that space. Angle LNK is opening down here. Are those angles considered adjacent? Two things you need. You need to share a side. Remember, our example of sharing a side was when your neighbors, side by side, they have the same fence line. Over here, they don't have the same fence line. They're not sharing the pink and the gray side by side. They have the same vertex, so you're part of the way there, but they're not sharing a side the same. So these are also non-adjacent. We flip to the other side. We have some adjustments we need to make to this picture. We need to put an arrow on the end. We're going to call this C and F. C is down below, and point F is up above. So we want to come up with our angles that are complementary, our angles that are supplementary, and then if we have any adjacent angles. So to be complementary, first thing you need to think about is what's the vocab word mean? If two angles are complementary, then what's our statement? What happens with complementary angles? They add up to 90 degrees. So look at your numbers. There's 50 some, there's 30 some. 50 and 30 is 80. Plus the extra sum, which is the extra 10, 80 to 90. So these two are 90 degrees. So that's, using your eyes, your pencil, or your finger, ABD is where the 52 is located. And angle BDC. Notice you always put the vertex, you always put the corner of the angle, the pointy end of the angle, in the middle. The B is the pointy end of the angle. It's in the middle. Using 3 letters to name an angle. Which angles are supplementary? We're looking for two angles that add up to 180. We have angle BDF. That's 128 degrees. To be supplementary, we have to have two angles. Two angles that add up to 180. So 52 plus 128, those add up to 180. The 50 and the 120 is 170, plus the extra 10 gives you the 180. So those two angles add up to 180. So they would be considered supplementary. Supplementary comes later in the alphabet. The S comes later in the alphabet. The 180 comes later on the number line. So supplementary is 180. Where complementary, the C comes earlier in the alphabet, 90 comes earlier on the number line. So complementary means 90 and supplementary means 180. That might help you keep track of which word, which vocab word is what value. Next, we're looking for adjacent angles. Two angles that have the same vertex. For example, here from CD to B, we have angle B that's opening up that way. And angle BDF that's opening up this way. They have the same vertex right here at point D. They share a side, and they do not overlap. The pink is in one spot, the gray is in another. So you could say that angle CDB and angle BDF are considered adjacent angles. Two angles that are side by side. Same vertex, share a side. So let's come over here to our next example. All the parts are there. Go ahead and list your two angles that are complementary, your two angles that are supplementary, and your two angles that are adjacent. You can pause the video, give this a try, and then start it up. We'll talk you through it. All right, we're back. Complementary angle, two angles that add up to 90 degrees. I see the 50 and the 40. So this 50, I can use three letters to name it. Angle DEF. The E has to be the middle letter. And then the other angle that's going to add up to 90 degrees, ABC. You could name it with one letter. This angle here, because there's no adjacent angles near it, you could name it with one letter, angle B, but three letters always works. Complementary are two angles that add up to 90. Or, I'm sorry, yes, complementary adds up to 90. Supplementary are two angles that add up to 180. So 180 is going to be our 40 and our 140. Remember, they don't have to be side by side. So angle ABC and angle FEG. Those two angles are supplementary. They add up to 180 degrees. Then adjacent are two angles that share the same vertex and share a same side. So I would consider the 50 and the 140 to be adjacent angles. Angle DEF and angle FEG. How did you do? Very nice. All right, here are questions that are on your quiz and your final exam, just the way they're written. You're going to be given information that angle 1 and 2 are complementary. We're given the value of angle A, and we're looking for the value of angle... Oh, sorry, I think I said A. We're given the value of angle 1, and we're looking for the value of angle 2. So the first thing we're recognizing is that angle 1 and angle 2 are complementary angles. Looking back at your notes, we learned that complementary angles, if two angles are complementary angles, then they have a sum of 90 degrees. So the given information tells you that they are complementary. So we know that the measure of angle 1 plus the measure of angle 2 equals 90 degrees. If we were doing a proof, that's what we would write next to it for the reason, if complementary, if was told to us, now we know that their sum is 90. Then we're going to plug the measure of angle 1 in. That is called substitution. You had a quiz last week, and it asked you to use substitution, and some people made a mistake and solved it. You told me what angle 2 equaled. Substitution is just plugging the 52 in for the measure of angle 1. That is your substitution. If this was a proof, we would give a reason of substitution next to it. Now we can do subtraction property of equality and figure out that we have 38 degrees. So those are the steps that we would expect you to have for solving these out. Not a magical answer. Be sure you start out with your equation, substitute in your value, and then you can do your own calculation. Same idea here. Notice that angle 1 and angle 2 this time are supplementary. So the measure of angle 1 plus the measure of angle 2 equals 180 degrees. We're going to substitute in 137 for the measurement of angle 1. And we can subtract our 137. And that comes up to be 43 degrees. So you go ahead and try this one that's dealing with some variables. We know that angle A and angle B are complementary angles. What's the measurement of A and what's the measurement of B? Pause the video, work through it, come on back, and we'll walk you through it. All right, we're back. We notice that angle A and angle B are complementary. Those are two angles that add up to 90 degrees. So I would suggest to have you start out with the formula. Don't just start out plugging in numbers. We're making everything obvious, just like our proof would be. Since we know they're complementary, we know their sum is 90. Start out with that step. Then do your substitution. 5x plus 4 plus 7x minus 10 equals 90 degrees. A mistake that some people make is they equal these to each other. These aren't equal to each other. They are complementary. They have a sum. They add up to 180. Not just one angle adds up to 90. Did I say 180? I feel like I just said 180. These two add up to 90 degrees. Not just one angle is 90 degrees, but they both have to add up to it. So then we collect like terms. If this was in a proof, we would not call this addition property of equality. We would just call this collect like terms. So we have 12x and negative 6. Add 6 to both sides. That's 12x equals 96. And I believe when we divide by 12, that comes out to be 8. So x is 8. We get all excited and we bubble in 8 on our final exam. And you don't get any credit for that. Because they've asked us for the measurement of angle A. So we need to come to the side and say the measurement of angle A is 5 times 8 plus 4. That's 40 plus 4, which is 44. That's what gets you your full credit. The measurement of angle B is 7 times 8. That's 56. 56 minus 10 is 46. So you have 46 degrees and 44 degrees. We'll come on down to example number 6. Let's give this one a try. We notice that angle A and angle B are supplementary angles. If they're supplementary angles, what does supplementary mean? Know your vocab. Supplementary means that the two angles are going to add to 180. So start out with that. Don't skip that step. Then substitute in your 7x minus 3 and your x minus 1. That's called the substitution property of equality. Then we collect our like terms. We add our 4 to get 8x equals 184. And when we divide by 8, we can do this without a calculator. 8 goes into 18 how many times? Goes in there 2 times, which would have been 16. So there's 2 more to get to 18. So we carry that 2. And 8 goes into 24 3 times. So I know my x value is 23. So you can do those calculations without a calculator. Just break it down into smaller parts. So again, we actually want to know the measurement of A. So that's 7 times 23 minus 3. 7 times 20 would be 140, and the 21. So 161 minus 3 sounds like 158. And then the measurement of angle B is 23 minus 1, which is 22. And together, they make 180. Last set of examples. These often are a little trickier because they don't tell you what's supplementary and what's complementary. You have to use the picture information. So can you decide, are these supplementary or are these complementary? If this side is 90 and this is a straight line, then this side over here would have to be 90 because together they have to make 180. All 3 angles are not supplementary. Supplementary has to be 2 angles. But these 2 angles over here do add up to 90 degrees. So if you know your 2x plus 3x equals 90, then you can group your like terms together and divide by 5. 5 goes into 9. How many times? 1 time. With how much left over? 5, 6, 7, 8, 9. 4 left over. So I carry that 4. And 5 goes into 40. 8 times. So there I come up with my 18. And you can do that without a calculator. So if we're looking for the measurement of angle ABD, that must be A out here and B in the middle, by the way. So it would be 2 times 18, which would be 36. And 3 times 18, which would be 54. Those are your 2 measurements of the angles that add up to 90. Last one. Here we have 2 angles that make a straight line. They also make half a circle. So you know that their sum is 180. These would be considered supplementary. They also have another special name. We'll call them tomorrow. These are supplementary angles that add up to 180. So we know that we have 4x plus 6 and 11x minus 6 that adds up to 180. People make a mistake and they want to equal these to each other. For one thing, they don't even look equal. And another thing, nothing tells us that they should be equal. So we take our 4x and our 11 to get 15x. And if you look at your numbers here, you'll see that the positive 6 and the negative 6 cross out. So now we have just 180. And when we divide by 15, we can say that x, the 15 goes into 18 how many times? 15 goes into 18. One time. So I write a 1 down. There's a remainder. It doesn't go in there perfectly. So how many are left over if it goes in there one time? 3. So I carry my 3. So now I have a 30. So 15 goes into 30. 15 times 2 is 30. So 12 is our x value. So now we can calculate out that 4 times 12 plus 6, that's 48 plus 6, sounds like 54. And 11 times 12 minus 6, that should be 100 and, let's see, 12 times 12 is 144. So I got to take away 12. So that's 132. And I have to subtract 6. So that sounds like 126. There they are. We calculated out the two values. These add up to 180. Over here, these added up to 90.